Good morning. We need to talk about what exactly a function is. We've used that word before, but I don't think we've ever quite defined it. Well, in order to talk about what a function is, we actually have to have a lot of vocabulary to go with it. So here we go. Function vocabulary. First of all, we have an ordered pair. Now, mostly we call this a point. It actually doesn't have to necessarily involve numbers. It's any pair of elements in which the first one has to be the first one and the second one has to be the second one. Order matters. For instance, if we have Sue and Rabbit, Sue has to be the first element and Rabbit has to be the second. Rabbit, Sue would be considered a completely different ordered pair. A relation. A relation is nothing but a set of ordered pairs. We usually put set brackets around it. And so we could take this first ordered pair, Sue and Rabbit, and it can be one point, but it wouldn't be very interesting. So let's add a couple more. What about Don, cat, and Mary, dog? So now this is a relation. Notice we don't have any numbers yet. The domain of any relation is the set of first elements. A lot of times we use X to represent the X, the first element, and then Y to represent the second element. So the domain is the set of X values. In this case, the domain would be Sue, Don, and Mary. The range is the set of Y values, the set of second elements. So in this case, the range consists of Rabbit, cat, and dog. Let's go a little farther. A correspondence is the rule which determines how the X and Y values get paired up. So it's the rule that tells us what goes with what. In this case, perhaps the correspondence is the person's pet. What they call the independent variable and we usually use that as X, the X value, or literally the X. The independent variable is the first one, the one we choose. The dependent variable which of course is going to have to be the Y, right? Is determined by the X value. Which pet gets put in the second position is determined by who we put in the first position. So if we look back at the other set, Sue has a rabbit. So if we choose Sue, the second thing has to be rabbit. Dawn's got a cat, and Mary has a dog. Well, you know what? We haven't talked about functions yet. So, drum roll, here we go. A function is a special relation in which every domain element corresponds to one and only one range element. So exactly one range element. All right, what does that mean? That means in order for our set to be a function, each person can only have one pet. Now, that doesn't sound very reasonable. We've got more than one at my house, but that's not a function. And it's okay to not be a function. What if we had the set of some points 3, 2, 5, 7, 4, -1, 6, 2. Is this a function? Well, our domain, this is super easy. If we could only have all of these. Our domain is simply 3, 5, 4, and 6. Just pull out the X values. Our range is the set of 2, 7, -1. 2 is twice. Do not list anything more than once. We typically do not list something more than once in a set. Now, this is not obviously going to be a one-to-one correspondence of any kind, because we've got more elements in the domain than we do in the range. However, this is a function because the 3 only corresponds to the 2. The 5 only corresponds to the 7. 4 only corresponds to -1. And 6 only corresponds to 2. Now, the definition doesn't say that it has to be a one-to-one function, in which case this last point would keep it from being a one-to-one function. However, it is a function because every one of these domain elements only pairs up to one specific range element. One way they might show this is called a mapping. If I take the domain and my range, and in my domain, I list all of the domain elements, and in my range, I list all of the range elements, and I notice that none of these are duplicated, but it's okay to have the same elements in the domain and the range. Now, my correspondence is just kind of random because I didn't throw anything specific out there, but I can show that the 3 is paired up with the 2, The 5 pairs up with the 7. 4, we call this mapping. 4 is mapped to the -1, and the 6 is also mapped to the 2. So this is called a mapping. All you have to do in a case like this to see if it's a function is only look at the domain and see if there's more than one line coming out of any of these. This is a function because only one line comes out of the 3, one out of the 5, one out of the 4, one out of the 6. It doesn't matter if they all go to the same element in the range. They just can't go to more than one element in the range. That makes sense? That's the way the rule goes. And the thing is, when we plug in an independent variable, we like it to only have one answer. It's okay if several of the variables have the same answer, but we don't want them to have more than one answer because that makes it hard to grade the test. So we can show a function as a set of points. We can show it as a map. A lot of times we'll put it in what we call a t-table because it looks like a lowercase t, and we put the independent variables down one side and then their corresponding dependent variables down the other side. There are many times we'll also graph them. If we had a graph, let's say here's a point and a point. These are just independent points. They're not connected. Now, I'm not going to draw a line between them because in order to draw a line from one to the other, that means that all the points in between those points also have to be part of the set. So this is just some independent points. They could be down here also. Now, when we graph a point, we know that we go over and up, over and up, over and up. So that might be back and up. Here we go. So every one of these particular points has a different x value. Since they all have different x values, and there aren't any points that are sharing the same x value, and I would know if they shared the same x value because they would be the same distance from the y-axis, the same distance to the left or the right. This is a function this would not be a function. Oh my, that means that we can't tell whether it's a function or not based on whether or not we could graph it. These 2 points have the same x value. So, like for instance, this might be the 0.12 and this might be the 0.15. But we know they have the same x value because they line up vertically. We have a test called the vertical line test, which states if it is possible to draw a vertical line which intersects two or more points on the graph. It is not a function. Easiest test you'll ever see. And this only refers to an XY graph like this on the Cartesian coordinate plane. What if we had a graph like this, a line? This is a function because there's nowhere I can draw a vertical line that crosses it more than once. So this is a function. What about a parabola? No vertical line is going to hit it more than once. A parabola is a function. What about a circle? Not a function. Now we can draw a graph of a circle. We can write an equation of a circle. None of those necessarily determine whether it's a function or not. But if the graph has points that line up vertically, they share the same x value. Here's the x value for those 2 points. So it can't be a function. What if we had this? Not a function. You only have to have one place where it's possible to draw a vertical line straight up and down through more than one point, and it's disqualified. This is not a function. If we had, let's look at an equation of a circle. If we had x squared plus y squared equals 9, and we solved this for y, we would have y squared equals 9 minus x squared. And to solve y squared, to reduce it down to y, we have to do the square root. But when you take a square root that wasn't already part of the equation, you have to put plus or minus. Y is plus or minus the square root of 9 minus x squared. So if I put in, I don't know, a 2 for x, then this becomes 9 minus 4 plus or minus the square root of 5. So 2 and the square root of 5 would be 1 point on this line, on this circle, sorry. And 2 negative square root of 5, because of this, would be a second point. So the 2 has 2 values. So a circle is not a function. And if you recognize the equation of a circle when you see it, then you automatically know that's not a function. So we're going to talk a lot more about functions as the time goes on, but this is the main introduction to it. So if you have any questions, let me know, and I'll talk to you later.